All right, it is. All right, so we'll do this. All right, and then we'll bring this up. That's coming up. All right. All right. So we're on the back of those notes. So we're using similarity in real world problems. And this is going to be a unique situation that normally kids are more successful in these because it's stuff they've been doing all their lives. There are some small little things though. All right, so the first one says you want to enlarge a 3-inch by 5-inch photo. The paper you will print is on 8.5 by 14 inches. What largest size can the photo be? So this is what you're going to do. You're going to figure out an appropriate scale factor. To do that, you match up corresponding sides. When I say that, the photo's small side is 3 inches. All right? The paper's small side is 8.5. So it's 8.5 over 3. The photo's longer side is 5. The paper's longer side is 14. You set up two ratios. You're not going to set them equal to each other because you're trying to compare them now to be able to figure out which one's appropriate. Now you're going to divide. All right, so you're going to have 8.5 divided by 3. Okay? And that becomes 2.83 repeating. And 14 divided by 5, which is 2.8. All right? You must pick the smallest. Because if you pick the bigger one, it won't fit. All right, so for those of you that like a step-by-step method, number one, you divide corresponding sides. Number two, smaller quotient equals your scale factor. The smaller quotient equals your scale factor. So whichever one's smaller is going to be your scale factor. So now you go back and you take the 2.8 and technically you multiply by both. Now one of them is going to come out to be the same number, obviously. The 2.8 times the 5 is the 14. So if you visualize that, you're fine. You just got to multiply the 2.8 by the 3 and you get 8.4. So step 3, multiply by original dimensions. All right. So you're going to multiply by the original dimensions. Good. All right. Company makes rugs. The smallest rug is a 2x3 rectangle. The largest rug is a similar rectangle. If one side of the larger rug is 18 feet, what are the possible dimensions of the longer rug? All right, Christina, where'd you get the 8.4 from? The part 3, multiplied by the original dimensions. So the original dimensions were 3 by 5. So I multiplied each of those by 2.8. And I get 8.4 and 14. The 2.8 comes from the smaller quotient. All right, good. All right. All right. So as soon as you see possible, what does that mean? More than one. All right. So more than one. All right. So here is, if you want to visualize, 2 by 3. So that's the original rug. All right. Now, here's the thing. Do they tell us that the 18 is the long side, or do they tell us the 18 is the short side? They don't tell us either, right? So you got to consider both. All right. So you got to consider both. So if 18 was the short side, 18 divided by 2 is 9. So the scale factor is 9. 9 times 3 would be 27. All right. If 18 was the longer side, all right. If 18 was the longer side, 18 divided by 3 is 6. 2 times 6 is 12. So keep that in mind when you do this. That might be one of those select all questions where you can pick more than one. All right. All good? You've seen a lot of this stuff before, correct? In previous math classes, similar figures, scale factor. Okay. So now more real world stuff. For our class, you need to make a scale drawing of the Parthenon using the scale 1 inch equals 5 foot. The Parthenon is 228 feet long. How long should you make the building in your scale drawing? All you are going to do is 228 over x, where that is feet, equals 5 feet over 1 inch. All right. I'm going to end up multiplying 228 by 1, dividing by 5. In short, dividing by the scale factor. And I get 45.6. All right. In the scale drawing, it's in inches. That'd be 45.6. All right. Keep that concept in mind. Please work on number 10. Let's see. Who I need to speak to? I talked to Sean already. He's good. Good. 85 miles. You end up multiplying instead of dividing. The one thing I'd make you aware of, and we'll review this before you would take a quiz, is the one thing we like to do is we combine that with like speed. So we would say a problem like, all right, the scale factor would be 1 inch equals 20 miles. All right. And we would say something like it is 4 feet on the map between the two cities, and they're going to drive 60 miles per hour. How long will it take for the trip? Something like that, where we're combining things. All right. So if 1 inch equals 20 miles, the 4 feet forces you to convert. That'd be 48, right? 20 miles, so 48 times 20 would be 960. So that means the total distance of the trip is 960. And then if they go 60 miles per hour, you divide by 60, and you get 16 hours. All right, so just so you're prepared and you see it, and again, we'll review that before the quiz. Okay, now a little more algebra. Find the value of x given the scale factor of the polygon. So All right, I look for the numbers. 3 and 9. All right, so I set that up, 9 over 3. You can reduce if you want, if that makes your life easier, makes your numbers small. All right, the other side associated with the 9 is the z plus 4. Associated with the 3 is just z. All right, so you just have the same variable. It shows up multiple times. Process is still the same. 9z equals 3z plus 12. 6z equals 12. Z equals 2. And then if you were asked to plug that back in, 2 plus 4 is 6. That's 2. All right. And there you go. Again, we may then ask you to find the length of the hypotenuses. All right. What would you use to find the length of the hypotenuses? Rhymes with Pythagorean theorem. Ladies and gentlemen, the easiest way is to do the small one, which is 2 squared is 4, 3 squared is 9. That's the square root of 13. These seem to be that times 3. Would you agree? So that means that hypotenuse would be 3 root 13. All right. So to finish up for today, if you would please do 14 through 19 on the right-hand side, reviewing everything. Couple more minutes. Here. Yesterday's video is there. All I gotta do is release your last quiz scores, not yesterday's first quiz, so I can release that to you. I think everybody's taking it by now. Okay. All right. Scale factor of NOP to WXY. WXY comes second, so please remember that that comes first. The two sides they give me are the 10 and the 4. So that means I would start with 10 over 4, which reduces down to 5 over 2. Good? Okay. The measure of angle X. X matches up with O, so that's going to be 58 degrees. The measure of angle Y. Y measures up with P. So that would be, I believe, 73 degrees. All right. All good? All right. NP over WY, ladies and gentlemen, would just be the inverse or the reciprocal, so 2 over 5. All right. WX, I believe, would be 15. And NP, if we divide by 5 over 2, I believe would be 4.8. I'm doing the math correct in my head. Everybody good? Thomas, how'd I do which one? 18, WX? Okay. So WX, which is here, corresponds to NO, which is 6. So my scale factor originally was 5 over 2. All right, WX is in the bigger, so that's my variable. And then what corresponds to WX and the other one is the 6. Good. Now we're just going to cross multiply. 6 times 5 is 30. 30 divided by 2 gives me the 50. All right. And then for 19 NP, all right, NP corresponds to WY. So same idea, 5 over 2. The difference is the 12 goes with the 5, and I'll call that Y. 12 times 2 is 24, and 24 divided by 5 gives me the decimal 4.8. If those of you in the room need a copy of the homework, let's do it right there. We're just going to walk through that real quick, and then you're good to go. All right. All right. After we go through the homework, those of you at home are going to be free to go. However, I need to see the following people to stay on: Lucas, Marissa, Christina, Ava, and Enzo. All right. So again, people I need to stay on: Lucas, Marissa, Christina, Ava, and Enzo. All right, so looking through the homework that's due tonight at midnight. All right, list the pairs of congruent angles in the extended proportion that relates to corresponding sides for the similar polygons. So, if, for example, in number 1, there's 4 sides. So you should have 4 pairs of congruent angles. All right, matched up. Shouldn't be that bad, right? A and W and all that. And then basically your extended proportion should look like that. There should be 4 ratios in your extended proportion. Number 2 is a triangle, so instead of 4, it's 3. You should be good to go. Good? All right, underneath, determine whether the polygons are similar. If so, write a similarity statement and give the scale factor. If not, explain. So basically, determining if they're similar, number 1, are the angles congruent? All right, and number 2, are the sides proportional? All right. Because they do not tell you what order to give the scale factor in, it can be either A over B or B over A. So if the right answer is 2 over 3, it could also be what? 3 over 2. All right, so don't worry about that part of it. All right, 7 through 10, they're going through properties. Remind you, 11 and 12, a couple word problems. 13 through 16, you're going with always, sometimes, or never. 17, you got a little algebra. 18, just reviews the different order in which you can do scale factor, and then 19 is like the last one we did. And then 25 says explain in writing why all isosceles right triangles are similar, but not all scalene right triangles are similar. Basically, it can be done in one sentence. It doesn't have to be huge. It doesn't have to be approved for anything like that. All right. So you guys got about 15 minutes if you want to get started on that. Those of you at home, unless I mentioned your name, are free to go unless you want to stay on. I'll address them and then I will stay on. All right. There we go. All right. Let's start with the easy one. Lucas, Christina, Ava, and Enzo, are you all good to go to take the quiz today?
Yes.
I'm good.
Yes. All right, so it will be open from 2:12 until midnight. All right, make sure you give yourself the proper setting and that nothing goes wrong. You don't have any emergency stuff like that, but you're good to go. All right, so that quiz will be up. Take care.
Thank you.
You're welcome.
Have a good day.
Yeah.
You too. All right. Marissa, you're still there, correct?
Yeah.
Okay, I'm going to stop recordings, and then I'm going to get the stuff up, and then we need to check so this can stop happening. Not anybody